Alright, I kind of wanted to, do a short little video about transistors and something that I realized once when I was younger, I think, but it's easy to lose sight of it because of all the crap you get overwhelmed with studying transistors. But I mean, this is basically biased like a Class A amplifier. I mean, fully. Although what I'm going to talk to you works especially well if it's actually set up, I think, as a common collector, in other words, a voltage follower. And that's the constant current source nature of a transistor, which is, again, it's easy to lose sight of because when you learn about transistors, it's a lot of times they'll start with a double voltage source, but they never really make it clear that it's actually a constant current source. And you lose sight of that because usually you're dealing with one power supply in a circuit, right? One for both biasing and for the the power to the load, etc. But because of that, it's easy to lose sight of because if you change that voltage, like it's set to 20 volts here, if you cut it in half, well, that does affect the current, or if you double it, it affects the current, etc. So it's easy to forget that this is actually a trans resistance device. In other words, it varies its resistance, but in an effort to try to maintain a constant current. That's fundamentally what a bipolar transistor does. And as you can see here, I got this going on false stat. Let's see, I'm going to save it. So that's what it's called. I don't know where to put this. I ought to just put this in with the same place the videos are stored. That's where I ought to put this shit. Anyway, I've got this set up to where it's got 10 milliamps flowing through the collector, okay? And you can see what the current flowing through the load is, which is actually a 100K resistor. It's set somewhere on the lower side of that. But the point is, I got it set up to where this should maintain its value no matter what I do to the voltage or whatever. It's an ideal transistor, so this will be truer than ever. But let's change the value, of the load. Watch the, no, whoops, I don't have this hooked up right. Hold on. Okay. Alright, so I'll change the value of the load, but you can see as the load changes, it does affect the resistance, or the current flowing through it, but it's still relatively insensitive to it, but it does actually affect it. It's
spontaneously, combustively transparent, and just let us know who wrote it and if it was him. Do you want to give him?
Okay, I had this hooked up wrong. But at any rate, as you can see, I've got it set at 40 volts, and I've got the resistances both maxed out, and you can see 10 milliamps is still there. Now watch what happens when I change the collector resistance. Okay, you can see the voltage changing, across the transistor itself, and this is the voltage at the voltage divider point here, because this meter is not connected to this. That's what was confusing me. It's connected to this. It's measuring the voltage across the transistor. But at any rate, watch what happens, because I can take this like clear down to 500 ohms or whatever. That's as low as it goes. It doesn't go down to zero, but it's as low as it goes, and you can see that the voltage increased up to 29 volt or 28 volts across the transistor. Okay, but we're still at 10 milliamps. All right, and of course the voltage, at a resistor is 29 volts. So so it doesn't pull it up all the way. Let me so it's a 1K resistor. But and if I go change the load resistor, you know, you can take it down kind of close to the, you know, closer to 0, you know, and you know, if I increase, I think this is working backwards, damn it. Alright. That's why I'm confused, god damn it. Okay, so both of the resistances are maxed out right now, and this is where it just works out, because this is 100K and this is 1K, but, you know, the transistor's drawing 10 milliamps, so that's having an effect on this voltage. Just keep that in mind. But now if I vary the collector resistance, I'm going to decrease it, you know, and you can see the voltage rises up to its maximum value that it'll obtain. But again, this is still affecting, you know, this 10 milliamps is still affecting the current through it. Now I can, you know, vary this, okay, and you can see the current through the resistor went up to 79 milliamps, so it's still only 10 in the transistor. And we're back to 38 volts being its voltage, but now I can take it, you know, that's as low as it'll get with this resistance up to full blast, and you can see with the current, but it's still holding steady, and you can, you know, make note of what the transistor has done this whole time. You know, every time I change it, you know, the voltage across it changes, but the current remains the same. And the same thing happens, you know, if I cut the source, lots of the current in that, and the voltage across the transistor changes, you know, and it doesn't affect it until it starts getting really low. You know, when the voltage drops within 5 volts or so, it starts to really affect the current, but, you know, at about, you know, 10 or 12 volts, you know, it stabilizes at 10 milliamps. And the only thing that really affects that or controls that is what the bias voltage is here. And keep in mind, this is still a Class A amplifier. It's fundamentally a voltage gain of 10 to 1, roughly, but the fact of the matter is it still maintains a constant current. So if there's a variation in this input voltage, it varies the current through the base, which varies the resistance of the transistor in essence, which varies the current through it. But that's still primarily what a transistor does. It tries to act like a constant current source. At least in this configuration it does. So, and again, you know, if you set it up as a common collector or a voltage follower, an emitter follower, you know, it'll do the same thing, but even better, because you got a voltage gain of about 1, and then it's like almost 100% just current gain, or voltage gain, current gain. So when it's set up as a voltage follower, in fact, that's how you know, amplify current with a transistor, is set it up as an emitter follower, amplify.
And this is the death toll in Texas has climbed to 30, including 3 young.
God damn it. Okay, but you know, that's how it works, you know, but you know, it can get confusing, because normally these two voltage points are connected together, and when you adjust both of them, you know, like if I were to take this to 30 volts, for example, or let's say take it to 40 volts just like the other, well, guess what? It's no longer 10 milliamps anymore. So, you know, that is why it's easy to lose sight of that. That's also why these work good if you put a voltage reference here instead of this 1K resistor, you know, like a precision voltage reference. You know, it also makes even a better constant current source, because it's better, more stable than these resistors are at producing a fixed voltage on the output. For these, especially if this were rigged as an emitter follower, you know, it would be especially stable and as a constant current source. Even though you think, hey, that's a good voltage source, but it's actually a really good constant current source, because it's got a really stable voltage to supply current through that base. And if this was set up as an emitter follower, it would be a lot more rock solid. So anyway,